During the Independence Day fireworks show, the height, h in meters, of a specific rocket after t seconds can be modeled by the height of t is equal to negative 4.9 times the quantity t minus 4 squared plus 80. So we want to identify the vertex, the x-intercepts, and the y-intercepts, and tell what each represent in the context of this problem. First off, let's start with the vertex because it's in vertex form. Think about your HK. I know the vertex is the opposite of negative 4, so it's at 480, which means this: after 4 seconds, the rocket reaches a maximum height of 80 feet. That's all the higher the rocket's going to go, 80 feet. That's what it tells me. All right. So to find the x-intercepts, I'm going to go back to the original equation. I want to solve for t, so I'm going to use square root law, which means I'm going to minus 80 from each side first, then divide by negative 4.9, and then I'm going to square root each side. And 80 divided by negative 4.9. I can use decimals because decimals are given up here in the problem. So when I square root this, I'm going to have plus or minus the square root of 16.327. I'm going to add the 4 to each side. So basically, what I need to do now is this. The square root of 16.327 is 4.04. So what happens is this. My x-intercepts are at 8.04. If I add 4 to 4.04, if I take 4 and minus 4.04, except the problem is I can't go backwards in time. Even 0.04 400ths of a second. Can't take that back. So the only answer is, it means this here, that at 8.04 seconds, the rocket has hit the ground. All right? So it takes 8.404 seconds for the rocket to hit the ground. All right, that's what it means. Now, to find the y-intercept, I would have to get this in a different format. So I'm going to take one that could go up to the original equation, put a 0 in. That would probably be the easiest, but I'm doing it in the format that they want. I'm going to square this here, and basically, if I FOIL this, the 4 is always double to make the negative 18. Negative 4 times negative 4 is 16. Take negative 4.9 times each of these numbers, all right, which I would got a calculator to do that. I can't do that in my head, but we can see negative 4.9 t squared. Negative 4.9 times 8 is going to be pretty close to 40, 39.2. And then negative 4.9 times 16, 78.4. Add the 80. I can add these two together. And basically, that means my y-intercept, if you put a 0 in here, is at 1.6. So the rocket starts 1.6 meters off the ground. That's what it means. The starting height of the rocket is there. A lot of information from this one story problem.